Don't worry, we made sure his microphone was QRO. What is up, Ham Radio? Kilo Echo 8, Papa Zone November, the Ham Radio Adventure Guy. Thanks for stopping by. Your one stop for everything Adventure Radio. It is Hump Day. Time for the Hump Day Happy Hour. And we got a great stream tonight. And we're going to talk about it in just a second after we thank these guys right here because they are absolutely awesome. And I appreciate each and every one of them. But we need 4 more of them. The end of this month is coming quick. And we need 4 more of them so I can get rid of this ICOM radio that's sitting up here in my closet because we all know that I don't want that setting up there. So 4 more Patreons, guys. You guys need to make that happen. Also, a big shout out to the YouTube members, the people in green in the chat, or maybe blue if they're administrators, and the ever-changing board, which did not change because of $1. There is a $1 spot up there. Somebody is in a $1 spot. So I would suggest if you're not confident about your spot, that you get rid of that $1 spot really quick. All right, Dan, what's up with you, buddy?
Not a whole lot. Braving the heat. Happy Hump Day, everybody. Good to see you in the chat. Let's see. Kilo 40 Ta. What is going on, buddy? KO4 FSZ antennas. I got your package today. Thank you. And Liz and family, Whiskey 8 Echo Romeo in the chat. Terry, Kilo 8 Golf Hotel. Yeah, good to see you. Larry, Loudmouth from Hammertown. Lima Bravo, India. Good to see you. Larry Bingham. George Broadway. Bang, bang, the Duke of Alabama. Brent, Bravo Delta Whiskey. Good to see you, buddy. Eddie, November Lova. Alpha Echo 4 X-Ray Oscar. Chris, what is going on in James? KI5OEB. Happy Hump Day, everybody.
Oh, well, you know what? One thing I've learned since I've been a ham is hams like to build crap.
That's true.
And what better stream to have than a stream about hams building crap? So we got somebody that normally we all don't want to hear from because we can't hear him because he's QRP. But we got him on a QRO microphone tonight. Matter of fact, if you look behind his shoulder, his microphone's bigger than his head, so we should be able to hear him. And he's going to tell us about some designing for Ham Radio 101.
What's going on, PG, man? Nothing much. I want you to tell the same story you told in the green room about you calling me while I'm activating. Because that's just too funny.
It was good.
Good. Got to tell it the same way now. Start from the beginning.
I'll gladly tell that story. So, Steve, if Steven's in the chat, Steven's working tonight, so he's not in the chat. But he could agree with me. This PP man is like a woman. They know where you're at, but they're still going to call you, and they're going to call you 500 times while you're doing it, even though they know you're busy. So every time I go to activate, no, I'm definitely not embellishing. If Steven was here, he'd back me up. Every time I go to activate, this guy will blow my phone up like 50 million times. And, I don't have time to answer that stuff. So I'm driving down the road one day, and I'm talking to Terry, Kilo 8 Golf Quebec. By the way, Terry, how's the new nursing home? Hope everything's good there. But I'm talking to Terry, and he said, oh, PP man just spotted on 14-3 something. I was like, oh, I got to go. He's like, why? I was like, I got to call PP man right now. So I call him just to aggravate him, figuring he's going to say, why are he calling me when I'm activating and not answer? But he answers. And this is the difference in a QRO and a QRP activation, because he answers, and not only does he answer, he'd end up calling CQ on his automatic CQ for like 2 minutes, and he'd talk to me, and then he'd like, hold on, I got a call, and he'd take that call, and then we'd talk another 2 minutes or 3 minutes, and he'd get another call, and I'm like, dude, I'm done activated by now. You've got 2 calls. What is going on?
And then I wouldn't let him go because it gave me something to do.
He was hoping that my voice would go over the radio.
Oh, there you go.
And bring all the people to the yard for him. But
wait. So you can't hunt like third party over the phone?
No. Well, he did try that with me before.
Yes, I did. That was with Steven.
Yep.
Yeah. And we got rejected. All right. So tonight we are going to do something that I do a lot, and that's use a online software called Tinkercad. It's designed for grade school kids. I know some high schools use it. I know a lot of adults that use it. It's very simple. It's kind of get your feet wet in 3D modeling, where you can export to a 3D printer. What we're going to do today is we're going to design something that everybody will know exactly what it is, and I'll show it to you before we start. It's a center section to a dipole, and we're going to go step by step. Some of it might be, way too guys, but you might learn a trick or two. But let's go ahead and get this started if I can find the right window here. No, I don't want to do that, do I? I want to do this. Did it come up, Dan?
Yep, I got you. Go ahead.
Okay, good. All right. So this is the work surface. There's a little cube up here. You can flip it around. You can look at it from different angles. You can scroll it with your mouse. This is what we're going to be building tonight. Okay. So we're going to set this off here to the side. And we're going to start all over from scratch. We'll move it out a little further. Okay. All right. First thing we need to do is we're going to go through the board here a little bit. On the side here, on the right-hand side, you've got a bunch of shapes. They call them basic shapes to work with. And above that, you got a little ruler to measure with. You got your surfaces, your work planes. And we'll ignore what's above that. We'll go over to the right-hand side. You got the cube where you can on the right button of your mouse, you can rotate the screen around, or you can actually come over here and hit the cube and the little arrows, and you can actually flip back and forth until you see, now we're looking at the bottom. So now we got to figure out which way's up. There we go. Now we're back to work plane. Okay. And then there's some other buttons up here that we'll get into. And then there's more buttons over here. They're all grayed out right now because we don't have anything on the work surface to work with. First thing we're going to do is going to go ahead and just grab a square, place it anywhere on the screen. And now if you look at this square, it's got white little corners on it. And anybody who wants to ask something, just ask in the chat, and Dan and James will answer it. You guys can still hear me, right?
Yeah, we can hear you. You're just messing with you.
Oh,
Again.
again.
Oh, come
right,
on. That was a really good pregnant pause, Gus. Yeah, give me some credit for that one.
Yeah, that was good. Okay, so you got a cube, and it's got these little handles on what we call handles on the corners, and then there's one at the top. You notice when I click on the handle, it gives me dimensions. And these are in millimeters right now, but you can set this up to be in English measurement, the Queen's English. So anyways, these can be manipulated two different ways. You can grab them and move them around. When they turn red, you can move them around. Grab the corners. You can shape it, or you can click a square and then just go into one of the numbers and type in whatever you want, like 30 millimeters. And then let's say we'll go ahead and make this one 60 millimeters. And then we'll make it 5 millimeters thick. Okay. Let's go ahead and look straight down on it. And these
Kyle,
little grid. Go ahead.
Yeah, Kyle has a question. He wants to know, can you 3D design me like you do one of your French girls?
My French curls?
Girls.
No. And
sorry,
I'm surprised that's not Terry asking that.
Well, in Kyle's defense, he might be visiting Terry at the new old folks home, and Terry might still be strapped down from his latest episode, so he might be typing for Terry.
Okay.
The only other questions we have so far, PP, will it run on Linux, Mac, and I believe this is browser based. So it will run on anything.
It's browser based.
Right?
So if you can get a browser to come up, you can get this to come up. Perfect. And it's tinkercad.com. You create an account, and all your stuff is stored on the cloud. All your files are stored on the cloud. You can download STL files to your computer. But once they're an STL file, it's basically one shape again, which can be manipulated, but can't be, and you'll see what I'm going to do here, it can't be exploded back out. And you'll understand what I'm talking about here shortly. So now we got the vertical section of our dipole center. Now we're going to put and there's probably 10 ways to do this. Right now I'm just eyeballing something that looks kind of good. And I'm going to bring it close. I'm going to highlight both of them. And here's some of the things that lit up here in the upper corner. I'm going to click this one, which is align. And I want to say align with this object, both in this direction and only that direction. And then I can bring them down, touch them together. There's still two objects. Go ahead and make this one 5 millimeters also. There's still two objects. But now if I come in here and I hit this button up here, which is called group. Now it's one object, one big T. Okay. What's that? Doo-doo?
Sounds like somebody's Discord's going crazy.
Somebody's Discord. I know.
Okay. So now let's dress this thing up a little bit. Let's put some lipstick on this pig. Let's go ahead and bring in a circle. And again, we're going to go ahead and adjust the height to 5 millimeters. And we're going to bring it in on the end like that and line it up. We're going to click it once, go up to the upper left-hand corner, and we're going to want to duplicate that. So we hit duplicate. And then if I drag it away, notice the other one stayed there. And now we got one on each end. Okay. And again, you can group them. And now it's one object. This was what I was saying about how simple it is. You can just use your imagination with any of these shapes over here, and there's tons of shapes, trust me. And then there's parametric shapes, which can be, you can add parameters to change whatever the function of the shape is. Like for instance, if you bring up a gear, you say, I want 55 teeth on it. You just tell it you want 55 teeth. You put in the pitch. We just went into a tangent. We can go there some other day. Next thing we want to do is we want to place our bracket for where the SO239 goes. Okay. So again, we'll just grab our square and then we'll manipulate it down to, let's make it 4 millimeters. And we can check our width. I think it was 20, or no, it was 30, wasn't it? Yeah. So we'll change that to 30. And then we're going to raise it up 5 millimeters off the top. And then bring it over and match it up there. Actually, let's just go ahead and move it up a little bit. There we go.
Okay. You raised it up 5 because the thickness of your piece is 5, correct?
Correct. That's 5 millimeters thick. So I just raised it off the deck 5 millimeters. You really don't need to. It'll still mold together. I just do it out of practice. And I think I got a SO239 here on the desk here. Let me measure this just to make sure. The square is 25 millimeters. Okay, and how tall are we?
So you kind of left out something there. How did you raise that off the mat? Because if you use your arrow keys, this is going to go up or down, side to side on the mat. So what did you do to raise it up?
Okay, see that little pyramid at the top, little triangle? Mm-hmm. So you click that triangle and you start moving it, and then you can actually physically come down here and give it a number. So if I drag it down, you'll notice that number goes negative. Now I'm below the work surface. The bottom of it is 6 millimeters below the work surface. So you can just, all you have to do is grab it once, click it once, and then, or click it and start moving it. And then you type in the number that you want it at, and it'll go up to that distance.
Because I figured that out the hard way this week.
Okay. So there's the square. Now we need a hole in it. That is 18 millimeters? 17 millimeters. Okay, so this is different than everything else we've used so far, right? This is hollow. It's grayed out, okay? That's called a hole, or a material remover, as a lot of people call it. And it's not in the right plane, meaning it's standing up as a cylinder. We want to lay it down. But let's go ahead and adjust it. We want it to be 15 millimeters by 15 millimeters. And we really don't care what the height is. Now, if you see there's arrows, there's one down here. And if I click this one up here, it's on the side. And then I click this one, it's on the other side. So you got your X and your Y and your Z. You can rotate this object on all three of those. We want to rotate it on this one, and we're just going to stay on the inside of the circle. If I go out here, I'm free flowing. If I go into this one, I'm in degrees, even degrees. Okay. If I go into this one, I'm in 22.5 degrees. So we want to make it 90 degrees. Okay. And then we move it somewhere over here. Okay. And then we can go over to front, and now we're looking at it. There's that arrow again. We can move it up to what we think is looking good. We can eyeball it, or we can center it up. Oh, it won't let me center up in this view without changing the grid. So I highlight these two, and I want to center it up. And I click this one, and I click this dot here, and it just lines the two up. Okay. Now we have what looks to be a penetration through that vertical surface with a material remover, as they call it. Okay. So if we were go and combine, what's that?
Just before 10 o'clock, just so you know.
It's before 10. Oh, yeah.
You said penetration.
Okay. So now I just combined those two, and look what it did. It took material away. So there's our first hole. All right. Let's go ahead and put this plane back down here. Now we need 4 mounting holes for that bracket, for that SO239. And this is something that I actually learned the hard way not too long ago, of grouping things together to make your life easier. So I know these going to be 5 millimeter holes. I think they are. Okay. And again, we're going to do the same thing. We're going to rotate it around so it's that way. And then we can copy it. So we go over here. This is the command we used earlier on the ends of the top of the T. Click this, and it automatically made a copy. And I'm accidentally grabbed a I don't want to do that. I want to find a space. There we go. And we want this to be 0, and I want this to be 18. These are dimensions that I measured earlier when I was making this one over here. Okay. So now we want to copy these again. So now you grab both of them and you hit copy, and then you grab this and you go up 18. Oh, that's up by 18 off the deck. All right, let's back that up. We can just grab it. We're at 7, so we want to go up. We want to go up 21. Okay. Now we can grab these 4. And this is where I learned the other day. Group these together now as a group and turn them back into solid material. Now I can position these over here, because if I were to group these and left them as holes, they would have disappeared into infinity. I would never see them again. So now we need to come over here and line up to this surface so we can get these lined up with the align tool again. Let's put the grid on this surface. We want to grab this one and that one, and we want to align off of this one. There we go. Now we got 4 holes. Well, we got 4 solid materials that we're now going to just click over here. And when I click the object, all 4 of them highlight because they're together. I got a choice. I can change the color. I can make them transparent. Sometimes that's nice to have if you've got many layers of material. We'll leave them as orange, but we want to change them into holes. And then again, you highlight the 2 pieces and say, I uncombined. So I did that backwards. I want to hit this button here, which adds the 4 holes into the bottom bracket. Now, this is kind of weak. This is plastic. You got to remember that when you're going to print this, it's going to be made out of plastic. So it's got a little bit of vulnerability to it. So we're going to add a little reinforcement. We're going to grab this little, looks like a G.I. Joe or scouting tent, and we're going to manipulate this. Let's see, we're going to want to go, no, we don't want to do that. We want to go this way first, and then we want to go this way. Like that. And then we're going to change the thickness of this to 4 millimeters. Okay. And then we're going to raise it off the deck 5 millimeters, which is the thickness of our piece over here. And we just grab the piece and put it in this, into the spot. Okay, what do we notice so far? We got a problem, right? Our base here is not wide enough for putting this stiffener in here and still passing the bolt through. No problem. So what we're going to do is we're going to grab the main piece that we have here. We're going to unexplode it, or explode it rather, to where it's separated back to here. Okay. Now we can grab this one piece here, and we can actually make it, let's make it, let's make it 34, and then on this side, we'll just make it 38.
Got a quick question from Larry. He says, can you sketch a shape that you want rather than using the primitives?
Not in this software. He's talking about like Fusion 360.
Yeah.
That's when you start basically sketching on a surface exactly what you want, and then you start giving it dimension, thickness. Those softwares are much more sophisticated than this, and you can do some really, really cool stuff.
So I guess in Tinkercad, you could make whatever shape that you want, really, but you're stuck with what you have, and you can adjust the thickness and things to make shapes out of them, right?
Correct. And I'm going to be making a custom shape or a custom tool, let's call it, here in a second. So we're going to go ahead and make all our adjustments that we want to make here. And again, Larry, yeah, this is a very Mickey Mouse software, but it kind of is a perfect software for getting your feet wet. The learning curve is really, really short. And if you get interested in this and you really like it, then yeah, I recommend you go into something like Fusion 360.
I was gonna say that this looks like it's perfect to get the job done if you don't know much about it without being overwhelming.
Yeah, exactly. So I've made all the adjustments that I need to make there to make my bolts clear. I can actually grab all of this now and put it back together in one piece right now. I don't need to do individual pieces. And then some simple stuff. Now we can throw this back down and plan. Let's look at it differently like that. And let's go ahead and give this thing a little rope attachment. Oh, we got to make this thinner because they come in as 20.
Hey, thank you, Chris, for the super chat. He says PP Man makes this look easy. And
it is easy. Trust me, it is easy.
I'm going to go ahead and say he does make it look easy, but it is extremely easy because I'm an absolute moron when it comes to stuff like this. And that field day coin that I give away the other day, I designed that in about 5 minutes before I went to the park, before I went to field day. So, I mean, it doesn't take rocket science to figure out. It's pretty easy software to use.
It is. It is.
It looks easier than running QRP all day for sure.
I knew that was coming.
You could not use this software while running QRO, but if you're doing QRP, you could probably design a tunnel that went through a mountain.
And right now, I'm free flowing. I'm not being real critical on dimensions. I'm just kind of putting stuff eyeball in just to show that you really don't need to be super anal. But you can be as anal as you want. Now, if you notice what I just did there, so I got one hole, okay, and I want to make 3 of these holes. So I'll say copy, and I'll move it over, in this case, 8 millimeters, okay? Oh, I did that. I screwed up. Okay, so I got that one copied. I copy it. I move it over. Okay, and before I do anything, I just hit copy again, and it moves the next one 8 millimeters over. And if I repeat, it just keeps doing it. So if you got something that you're trying to repeat over and over again, you just keep grabbing the one, and you can copy it as many times as you want. Now I'm going to grab these as a group. I'm going to say copy, and I'm just going to eyeball it just for fun. Like I said, you can be as anal as you want with this stuff. And we're going to go ahead and...
Larry wants to know if Fusion 360 is a free software. I do not know that.
There is 2 versions, a paid and a free. The free one is pretty complete. It's pretty good. And there's others out there. I'm going to say, without being too far off, there's probably 20 good 3D modeling softwares out there for this kind of stuff, for being able to 3D print. Some of them get very sophisticated, way more sophisticated than a ham needs to be. That's for sure. Now we're going to go into what Dan was touching on. Let's make a tool. I need a tool. I want to round the bottom corner of this right here. I don't like that sharp edge, okay? And I want to round it. There's no shape in here to do that. There's only 2 holes. There's a square hole and there's a round hole, okay? So you take a square solid and you bring it down to something even, like 5 by 5, okay? And then you take a circle and then you bring it over here and you make it 5 by 5. And these are the tricks that you'll learn as you start playing with it and your imagination starts to roll. You can do, oh, I'm sorry, this needs to be 10 by 10. It's twice the size of the solid. Okay. And then I line them up like that. And then I combine these two together. So now I've got a shape that looks like that. But that doesn't do me any good. So I click it here and I turn it into a hole. Now I can take this and I can rotate it around. And I can place it here on the corner. Boom. And then let's look down on plan. If I click that one and I say copy, and I go over to the right-hand corner, I'll see two little objects and it says mirror on them. I'll hit mirror and it'll ask me which direction you want to mirror it. I'll want to pick that one. And then I take that piece and I drag it over here. I highlight those three pieces and combine, and voila, we just rounded the corners off. So you can make tools with all these shapes. Just let your imagination roll. Here's a good example. I'm going to take this squared block. I'm going to take this cone, and I'm going to flip this cone over. As soon as I find my arrow to flip it over, this one. Okay. And I'm going to raise it off the deck. And I'm just going to, let's get it. That's too high off the deck. Let's go down a little bit. Okay. And let's put another one in here. And we're going to make this one 5 by 5. I'm going to turn that into a hole. Okay. And then we're going to line all three of these pieces. Let's change this here. Let's go up and down. Okay. So let's take all three of these pieces and let's line them up to the cube, both directions, and then combine them. Oh, look at that.
Made a canonical hole.
Yeah. And this cone can be adjusted. So you don't want that much cone. You can make that cone real shallow. Just like if I were to explode this back out, I can raise this up, change the whole pitch of that hole so it looks more like a countersunk screw.
I was just about to say, is that the way you would like chamfer a hole if you had to?
Yeah, yeah. And you could soften the edge of the top of this countersink. You could soften it. You could soften the corners of this cube. The imagination rolls. It's limitless what you can do with this. You can go and chamfer these corners up here with that same tool that I made, just by looking at it in this view here, putting that same chamfer on those corners. You can get, guys, here, I'll go, let's do this. Let's go back into my catalog and let's go to everybody's familiar with this. This is my boneyard for the PP spike. When it's done loading here. Come on, you can do it. But there's the PP spike. That's the last generation of it right there. That was all done in here. And those holes are the shape of the spike. So you can do quite a bit in here. You don't need to, be scared of saying, well, it's limitless. It's limited to what you can do. I think you can go into let's see if I can go into people's projects here. I think I can do it that way.
There was a comment earlier. You can make all the wire winders you wanted.
Oh God, yeah. Yeah. Okay. So this is kids or other people, adults, whatever. This stuff was all done in Tinkercad. See if we can find something that's pretty out there. There you go. That's pretty out there. That's some time. Like I said, it's pretty simple, but yet you can get very, very sophisticated with it. You can do threads. Let's go back to what we were working on, and I'll show you some other things. So all these shapes here are what they call the basic shapes. Okay, these are non-parametric, meaning the only thing I can do to this square is make it taller, make it bigger, make it thinner, move it around. I can't really alter its shape. But if I go into what's called, then there's other stuff in here, like you can bring in hardware if you want a gear or something like that. There's more shapes. Then there's another section for electronics, vehicles. So you got wheels that are already designed and stuff like that. Then you go down to this bottom one here, and there's a shape generator. And let's just go ahead and use this screw. This would be the male of a screw, but you notice when you click on this piece, you get a lot of things you can change. So if I want to make it bigger in diameter, just change the diameter. I want to change the pitch of my threads to, let's say, 2. And I want to make it taller. You can adjust this all you want, and then you make the female to it. How do you make the female? Very easily. You take this piece here, turn it into a hole, okay? And then you take another square. We'll just explode this one here for this purpose. I'm going to make this a little bigger. Bring this over here. Together. Now I got the female version. So you really only need to make one. The other one becomes automatic. Now you have to tolerance them a little bit, meaning you have to make, before you would turn that one into a hole, you would make a copy of it. Okay. And that one's the hole. And then you would make it, let's say, like right now I've got it at 20.99. When you get more experience, and depending on what filament you're using, this might end up being 21 and 21. Okay. And then when I bring my square over, no, I don't want to do that. Now I make my square bigger. We'll call this the nut. Now this piece, when I print them, because there's a tolerance built into there, they'll screw together. And now I can go back into basic shapes, grab one of these, raise it up, change the size of it to 30. I can actually make an Allen cap screw by putting these pieces together. And then you go and take this piece here, shorten it down, raise it up. Oh, don't grab the wrong button. Raise it up some more. And everybody knows we're going to turn that into a hole, right? And then combine these two pieces. There you go. Voila.
Magic.
How much easier does it get? And if you really want to be anal, which I have been lately, see how this is kind of stepped? It's got sides to it.
Yeah.
Before you go ahead and turn it into a bolt and everything, you go back into here and you can change tip segments. Not that. Is it oh yeah, here it is. Segments. Now it's more rounded. Why didn't you keep it? There we go. So now it's a smoother screw. keep in mind the screws you're going to do need to be big. You don't think you're going to be doing 3 millimeter or 4 millimeter screws. The plastic that's not refined enough to be doing fasteners that are that small. You can invert this. You can turn it into a jar. So you have a, say you want to make a canister. Make this one 30. Let's make this one 24. Oh, 24. And 24. Bring this over here, align them so they're in the same spot. By this and that. No, you didn't do it. Why not? Align by this. There we go. And then raise it up a little bit so we have a bottom. And combine. And so you could put threads on the outside of this, or I'm sorry, on the inside of this, and make another canister that's the same size and do the reverse for the threads. So you would have a screw top canister.
The possibilities are endless.
They are. I mean, they are. So here's, a lot of people see me put text on stuff. Let's go ahead and just adjust this here. Now this text works the same way as everything else. I can rotate it around. Oh, let's try. Come on, you can do it. Sometimes it takes a while because it actually has to go back. How about we do it in uppercase? That'll look better. And then you can adjust the length, how thick it is, and we'll turn it into a hole or a material remover. Depending on how deep we want to go. You want to just go a couple millimeters deep.
You don't want to go too deep in that guy.
Yeah, well, and again, when you start getting into printing, you'll learn that if you go too deep, I'll go ahead and combine them, and you'll see what happens. You get quite a deep cavity, and what's going to happen is you're going to get sag from the printer. So I typically only try to stay a couple millimeters deep, and actually I went right into the threads, didn't I? Look at that. So I usually only go in a couple millimeters. So I'll shut up, Dan.
Y'all ain't right. Y'all ain't right. Don't even say it.
Oh, come on, stop grabbing things. I'm trying to grab two things. There we go.
It's that WD4DAN guys messing you up.
Yeah. See, so I'm only in a little bit. So when it goes to print, it'll print better. The only way to get something really deep to print good, you'd have to actually take this piece, and you can print it this way. But now the problem you have is this shape here would be a mess when you went to, because we call this a bridge, the top part. Mm-hmm. And when you go to print, the printer is it unless you use supports, which supports are a pain in their own right, it won't bridge that far. So you'll get drop off, you'll get filament that's falling, and your hole won't be clean. Your threads definitely, if this were threads, like if you were doing threads, you would definitely want this to print this way. That would be your primary thought, is the threads, is to get them to print that way. This screw, you would not lay it down on the printer bed. You would print it in actually, what you would probably do.
You would print it cap down.
No, I guess it would probably print best in this position because the overhang is not that great up here. The printers can handle this. if you turned it upside down, the whole thing, it's not even a piece yet, is it? Stop doing that. So if I make this 1, okay, so if I go ahead and turn this way, you could print it that way, but the problem you'll have is this is going to get nasty in here. So you could put supports inside when you print, which in this case, I probably wouldn't be too afraid to do that. I would put supports in there. Well, otherwise, the roof of that hole is going to sag.
I've never made my plastic bolts Allen head like that though. So I've always just had flat caps. That's why I print them upside down.
Yeah, you could put a slot in it. You know, you didn't have to be an Allen. You could do this instead of making it flat on top. You know, you can give it a dome shape on top of the screw. And then put a slot through it, and it'd be a slotted screw. You could put a cross in it and make it a Phillips screw. And some materials will actually be again, you have to line these up.
Yeah, what PP Man's not telling you is the designing part is the easy part. Getting your design to actually print, that's what will have you throwing things and pulling your hair.
Yeah, there's days. There's days. So anybody got any questions?
I got something that might be handy for you to show.
What's that?
Start you a new thing there.
Okay, let's just clean this table. Let's clean this up here. Doop, gone.
Just do you a big long block across the thing.
Big long block. Like how big? Like the whole thing?
That's fine. That's fine. It
How
ain't gotta
thick?
be. That's fine, right there. Now,
okay.
I want you to put 7 screws across the top and 7 screws across the bottom, and show people how to make sure they're all evenly spaced.
Oh, okay. What would be the best? 7 as an odd number. So
okay, we'll do 5. Do 5.
Okay. Well, here. Let me show you the easy. Let. Oh Lord, these little squares here are all 10 millimeter squares. Okay, so we're gonna make it easy on myself here. Okay. Now, there's 2 ways of doing this. You can just notice it's not on the 10 millimeter. Come on. Okay. There's 2 ways to do this. We're going to do it both ways. We're going to do the one on top one way, and we're going to do the ones on the bottom a different way. We're going to put screw holes. We don't care what size hole they are. Okay. We're going to use that ruler that we haven't used yet, and we're going to plop it right there on that corner. Okay. So now we're designing the part. We know where we want the screw. We're trying to mimic a part, like in case of this SO239. I can dimension what the hole is from the edge. Okay. And there I put the ruler on this corner, so it's telling me that the side of this hole is 8 millimeters away from the edge of the plate, let's say. Okay. And I want to put a few more holes, and I want it across there, and I want them to be a certain distance. Okay. Now I know that hole is 47. The first one was 8, so I know it's 39 millimeters away. I want it to be 40 millimeters away. So I just click it. All I did is I clicked the arrow on my keyboard to move it 1 more millimeter, because right now we're snapping to 1. And I'll show you how to adjust that here in a second. So now that I've moved it 40 and I want another one 40, I hit copy again, and it knows I just moved it 40. So now it just copied another one 40, and I click another one again 40. Okay.
Okay.
So the other way of doing it is, let's put another hole here at the bottom, just randomly. Okay. And then let's go ahead and move my ruler down here. Is you can using your arrows on your keyboard, you can sit there and click it. Well, I got to copy it first, don't I? So now I've copied it. I can just sit here and use my arrows on my keyboard and move it over exactly how much I want by counting. If counting by ones is too much, you go down to the bottom of the screen here. You can adjust this. You can adjust it off down to 0.1 millimeter or as much as 5 millimeters. So now every time I move my arrow, it moves over 5 millimeters. And then I can let go of that one and I can copy it again and move it over X amount of millimeters again. That's another way of doing it. I like doing it with the ruler and then watching my tape measure. And that ruler you can place anywhere. And you can also notice it's telling me it's 8 millimeters off the edge. If you click this, now it works off the center of the hole. Now it says the hole is 18 millimeters off the edge from the center. And it tells me my hole is 20 by 20, but the green dimensions are the distance dimensions. So I'm 17.9 from the top and I'm 18 over from the top, from over. But I want it to be 18 and 18. So I'll type in minus 18. So now it's exactly the same distance off the corner, the two corners, the two edges off this plate. And same with these. Now, okay, I said I screwed up. I wanted them all to be 18. So I hit the shift key. I grab all these and I say minus 18. And they're all lined up again. Did that answer your question?
It does. Larry wants to know if you can save the SO239 design for another project. So I'm guessing he's meaning your.
Oh, most definitely. Most definitely. I'll kind of simplify. Well, here, let's do this. Let's blow this away. I haven't done this in a while, so it's good that he asked that. Thank you. All right, so I want to explode this. This is from earlier. Keep exploding till I see the holes that I want to see. Okay, there we go. So let's just get some stuff out of the way. Here's another thing I didn't show you guys. So if I click things that I don't want to see right now by holding the shift key, come on, I can hit this light bulb up here and then make them go away. Get things out of my way. They'll come back. All I need to do is turn the light bulb back on. Okay, so let's hide this. Hide this. I'm just hiding just to get things out of the way so it's easier to see. All right, so there's my SO239, right? I'll go ahead and group these together. And I would recommend leaving them as a solid. Okay? And what you do with this is you go to your creations, okay? And you click this and you say create shape. That's my shape. And you can give it a name, a tag. We'll call it SO239, okay? And hit save. Notice that showed up in my create shapes. These are my shapes. They only show up for me, nobody else. So if I want to go into my library of shapes, I go up here and I go your creations, and notice the one on the third, the one over here, that's my corner that I always use, and I can bring it in and I can adjust it to whatever I want. I can make it a 3 millimeter radius, and I can use that to chamfer off a corner. But yes, so you can make a creation. Now, when I go to use this, I bring it in and then I position it how I want. First thing I want to do is I'm going to turn it into a hole. And then I can put it on anything I want.
Great question, Larry. You actually just saved me some time because I can't tell you the times that I've created things and then just had to go back and recreate the exact same thing later.
Yeah, so I created this chamfer for you guys because I wanted to show you how to do it, but I got one in my library because I use that a ton. a ton. And you can have as many, custom shapes in there that you want. Colors don't matter. They're just a visualization. And then to bring everything back that I hid, because everything's gone right now, I just click this big light bulb up here and boom, everything comes back.
Questions for the PP man before we wrap this up? Let me go ahead and kill your present there. Bring you back up here full PP.
Am I done already? Did I talk for an hour?
Time flies, doesn't it?
Almost an hour.
All right. If anybody wants to see this again at a more sophisticated level, let us know, and we could do another one, because there's a lot more tricks that I could teach that you could easily learn yourself by just playing with this software. But we could easily do another 1 hour session.
Yeah,
and if
there's go leave comments in the actual video. Don't leave them in the chat here. Leave them in the actual video of what you'd like to see. Maybe if you'd like to see a Fusion 360 one or whatever.
We can move in that direction, definitely.
We can move in that direction, or whatever you guys want to see to do with this, we can do this. So it's that simple, but really it's fun to play with. I mean, like I said, I'm an idiot when it comes to this stuff, and I've been doing it. So
yeah, it's definitely a lot of fun.
Yeah, a lot of great info. I learned a lot about tinkercad and CAD in general. I'm really not a designer, so seems like an easy way to get into designing if you don't want to go through the I'm not going to call it pains, but I've done a little bit of Fusion 360, but it's a little more of a learning curve. But
yeah, everything I do is been done in tinkercad. I know how to use Fusion 360. I'm really rusty, but I've been able to do everything I've done so far with tinkercad. It's kind of Mickey Mouse on the surface, but man, it does some pretty cool stuff. You just got to be imaginative,
So easy, the adventure guy can do it.
There you go.
Yeah, look at that. He's a work in progress.
Oh, hey, thank you very much for the super chat, Eddie.
Yeah, anybody wants to do this again, let me know. I love it. It's fun.
That's all what right. You designed your Oreos in then.
The Oreos were probably one of the very first things I did. Yeah. If
I could just get him to correct that one screw problem in Oreo, it would be just gold. But
I've outgrown the Oreo.
Huh?
I've outgrown the Oreo.
I'm just saying, if I could just get you to fix it. I love that antenna, but I have two of them. I have the original, and then I have the King version, and both of them, that one screw came loose on the inside. And
yeah, I know which one you're talking about. Loctite. There you go. Loctite.
I just use a two-part epoxy. It ain't going nowhere.
That's permanent.
All right, guys.
Sometimes red Loctite is pretty permanent too.
Right.
We are getting ready to head over to After Chat. If you do not know what After Chat is, it is a Patreon benefit. But lucky for you, if you want to become part of After Chat, you can go over to Patreon and get a free 7-day trial. And then you'll message myself or Dan in Discord, and we'll get you in the room tonight. And once we get you started on the benefits of Discord or Patreon, you ain't gonna leave it. I'll tell you, because those guys, they're lifers now, man. Not like, I'll tell you what, it's a great group of people, and you can't beat the place. But anyway, we're heading over there. As for me, I'll be activating and dropping videos almost every day. So activating every day, dropping videos almost every day. Thank you guys for your supports in the super chats, and we'll catch y'all on the air. 73.
See ya.
73, y'all.